In this video, I'm going to go over how to find zeros and intersections using the TI-84 calculator. Finding zeros of a function is one of the capabilities you need to know in AP Calculus, in addition to graphing a function inside an arbitrary window, which we will also do. Intersections is a very useful capability to have in addition. Beyond AP Calculus, it's also useful in classes such as Algebra 2 and Pre-Calculus. So we'll move to the first problem. Consider the function y equals 2 sine of 3e to the x divided by 4 plus 1. We'll determine the zeros of the function on the interval between 0 and 4. So load up our calculator and plug in the function. Alright, so once we have this, we're going to go ahead and graph it in just our standard window, which is negative 10 to 10 on the x-axis and negative 10 to 10 on the y-axis. So if we're looking for zeros on the interval from 0 to 4, this window is not very useful to us. There's a couple points, but we can't quite tell where they are. Plus down here, there's several more zeros. So we need to change our window to be between 0 and 4 for the x values. The y values, it's a little tough to tell, so the easy way to do this, and the way that always works, is to look at your table. And we know for the x values we need to be between 0 and 4, so we look at the y values between 0 and 4 and figure out kind of the low and high. So between 0 and 4, we're going to get just about almost negative 1, and the highest point we're hitting almost 3. So we'll set up our window from 0 to 4, and our y will go from negative 1 to 3. And we'll keep our scale at 1, and this should give us a window that allows us to find the zeros on this interval. Alright, so remember our scale is 1, so each notch here is 1. So our first 0 happens between 0 and 1. And our next 0 happens between 2 and 3. So when we go to second trace, which is our calc menu, we're going to do 0, which is number 2. In order to find our zeros, we need to have a left bound and a right bound for the calculator to look between. We know this one happens between 0 and 1, so our left bound will be 0, and our right bound will be 1. And it's going to go ahead and guess for us. Alright, so our first 0 is at 0.801. Okay. If we want to find this 0, we're going to do the same thing, second trace, number 2 for 0. But this time for our left bound we'll go 2 and our right bound will be 3. And we'll go ahead and guess there. And we get 2.609. Okay, so there's our bounds, or our zeros. Okay, so we'll go ahead and reset our calculator, and we'll go to our next problem. Alright, determine the points of intersection of the graphs y equals ln x and y equals x minus 2. Alright, so let's go ahead and plug those in. And x minus 2. Okay. And again, we'll look at our standard window from negative 10 to 10 on both axes. Okay. So it looks like it hits right here, and we know it hits right here. So we have two possible points. Again, this window is not easy to see. We know natural log is going to be here at 0, so we'll start at 0. 1, 2, 3, 4. So maybe 4 would give us enough on the x from 0 to 4. We know x minus 2 goes through negative 2, so we can start there, and we can go up to 2 should give us enough. We'll try that. Or if you do it wrong the first time, it's not a big deal. You can just do it again. Our y max will be 2. We'll see if that works. Right, here's natural log, and then x minus 2. Okay, so we have this intersection. It's right here, just barely in the corner of the screen. I kind of want to get more of that, so I'm going to make my y go down to -3.
Ms. Cote Brown, please call extension 2005.
Sorry for the announcements. Alright, so this is a little easier to see, and we have this one here. So finding intersections can be similar to how we do zeros. We go second trace. Intersect is number 5. The goal here is that we need to get our cursor. We need to select both our curves, but we need to get our cursor close to the point of intersection. So we're going to move it over here to the left. Unfortunately, we cannot plug in a number this time. We actually just had to move the cursor. Okay, so first curve, second curve. Let's go ahead and guess for us. Alright. So this is 0.158, and our y value is -1.841. Alright, so if we want to find the other point of intersection, the one over here, we're going to do the same thing, except we're going to move our cursor to the right, closer to that point. Alright, first curve, second curve, let's go ahead and guess. There we go. 3.146, our y value is 1.146. Okay. Again, so our intersections are where these two graphs connect, which means we're really solving natural log of x equals x minus 2. We're figuring out when these are equal. This is also useful when you have problems that ask when a function equals a certain value. You can do this same thing. You can graph the function, and then you graph the constant, which is just a horizontal line, and then you can figure out where they intersect, and that will give you the x values where these are equal. Okay? That's going to be it for this video. I hope it was educational.